Teachers, please let your students know that they can now pay for the AP exams. The cost is $95 per exam. Checks are to be written to Dixon High School. Please let them know that the fee is due by November 6th. Payment must be brought to Dee Dee in the GO. Please let me know if you have any student. I'm planning to order tests for all enrolled students. Please remind them that if they say no to the exam and then change their mind after November 13th, there will be a $40 fee added to the exam fee.
To each exam? If you change your mind and don't want to take the exam, you have to pay more?
No. If you're saying right now that you're not taking it, and then you're ordering it late and change your mind at the end, then a fee gets added.
Wait, November what?
You get part of your money back if you pay now and then decide you're not taking it.
Okay. When do they need the money by? November
6th.
Oh my gosh. That's like 3 weeks away. All I know is my paycheck.
All right. Blame Hodson. It's not his fault either, but
I'll just blame him.
he's the one that sent me the email with the reminder, so blame Hodson.
I thought that they were cheaper this year or something. Is that cheaper than normal?
All right. Wouldn't that be nice of them to do?
It won't let me take any other classes, but if I say I'm going to take an AP class, it's like, okay. But everything else on my list is like, nope, can't take that.
Chapter 3 is all about scatterplots. And so hopefully you have seen and worked with scatterplots before. A little bit, so some of this should be a bit familiar to you. So, what a scatterplot lets us do is it lets us determine the relationship between two different quantitative variables. So if we have two different quantitative variables and we want to get the relationship between the two of them, then the scatterplot is the best way to do that. So for example, the trend that is going on here is that I have temperature on the x-axis, and then we have sales of ice cream on the y-axis. And we want to think about, on the x-axis, we usually want to put the explanatory variable on the x-axis and the response variable on the y-axis. So explanatory variable is the what you might have called in your science classes the independent variable, versus the response variable, which you might have heard called the dependent variable. Because the dependent variable is going to depend on the other. So on the x-axis, you're going to put your explanatory variable. This is the variable that we think explains the response variable. So we think that there might be some sort of causing factor between the temperature and the ice cream sales, and we think it's in this direction, that the temperature is having some effect on how much people are getting ice cream. We want to establish which variable we think is causing what. Because if we put it the other way around and put the wrong thing on the x-axis, then that means we're trying to imply that as more people buy ice cream, somehow the temperature goes up, which doesn't make any sense. that somehow ice cream magically makes it be warmer. That's not what's happening. What's probably happening is as we get warmer weather, more people want frozen treats like ice cream. And so that's the relationship that we're establishing here. So as temperature, in Celsius, by the way, this is not like below freezing temperatures. Temperature in degrees Celsius, and then sales of ice cream. As temperature goes up, ice cream sales go up. So in this case, the explanatory variable is our temperature, and the response variable is the ice cream sales. Now, there's not always a clear association or causing factor in these, but it does let us give a different set of being able to compare how one variable is affecting the other. Even if it's not a causing factor, how is one variable affecting the other? You want to make sure you're labeling, make sure you have a scale. Sometimes when we talked about like bar charts and histograms, we had this area principle where we made sure that everything started at 0, because otherwise it caused things to be misleading. In a scatter plot, that's not the case. We don't have to worry about that. We can start the data at wherever the data starts and end our scale wherever the data ends. So in this case, starting at 0 wouldn't really make sense, because then there's no real data down here, and then the scatter plot is super bunched together, and it's really hard to see what's actually going on in the scatter plot. And so it just depends on kind of the window of values that we're looking at. So, 4 key features of a scatter plot. This is the big idea of today. Strength, direction, form, and unusual values, or outliers. Kind of like how we have our shaped outlier center spread. We're going to have those unusual values, but we're also going to have direction, form, and strength. And if you're asked to describe a scatter plot, to describe the features, these are the things you want to say: strength, direction, and form. Let's start with direction, because it's the easiest. Direction is, you can think of as like the slope of your line. We use this word correlation, which is how much one variable depends on another. And the reason I say that is because usually we talk about something either having a positive or a negative correlation. This is what I mean by direction. So a positive direction would be as one variable goes up, the other goes up. So our ice cream sales and temperature had a positive association. As one goes up, the other goes up. Negative correlation means as one goes up, the other goes down. As one variable goes up, the other goes down. And then if we don't have a strong direction in either way, then that probably means we have no correlation or no association between the variables. So direction, are we generally going up or down as x goes up? Form. Usually, our form is going to take the form of a line. of a straight line. So these have, I would say that these have a linear association. This is a positive linear association. Here's a negative linear association. But if there are different curves, or it's clear that there's not a line, then we could have things like exponential growth and decay. That would be a nonlinear association. We could have logarithmic change, if you remember talking about logarithms. That type of logarithm curve, you can often use that kind of scale. We'll talk about it in chapter 12 when we started to talk about the exponential growth of how the COVID cases start to spike. Then that is an example of a nonlinear growth. This would be more of like, maybe this is a quadratic, a parabola, but some kind of curved nature. So we want to make sure that, usually in this case, is it a linear association or is it a nonlinear association? And usually for this chapter, it's going to be linear. That's form. And then strength is how well does this line or curve that you're fitting the data with, we're eventually going to have like a line of best fit that we're going to talk about soon. How well does that fit the data that we're looking at? And so just as an example, these are both positive associations, as one's going up, the other's going up. And these are both, I would say, linear associations. We would use a straight line to fit the data. But one of these has a stronger association than the other. So this data is much stronger association because the line that we would draw, which would be somewhere around here for both of them, the line that we would draw gives much better predictions here than it does here. That's what I mean by a strong association. And we'll actually have a number that we'll talk about tomorrow that will be able to measure how strong the association is. And then unusual values. So we could have an outlier. So we have all these data. We have, a fairly linear association. Maybe a little bit positive as one's going up, the other's going up a little. And then all the way up here, suddenly, what's this doing here? So we might want to talk about that value and single that value out specifically and talk about it. Why is that such an extremely high value? What's going on with that data? Well, we need some more context to be able to talk about it. Or it could be that we have a cluster of values. So maybe we have this nice association here. We've got a nice, neatly fit scatter plot. And then up here, all of a sudden, are these other values. That it's not just one value, it's quite a few values that are way off. Even if it fits the pattern, that we might want to talk about how well, what's happening with this data. So, first example. We want to give the features. What are we measuring the size of? If we're in carats. Maybe gold. We can go with gold. Or like diamonds or some other type of jewel. So we'll go with gold. We'll say that we're measuring gold. And so usually I go in the order of strength, direction, and form. So my sentence will be, there is a, so is this a fairly strong or fairly weak association here? That's fairly strong. So strong, direction, as one's going up, what's happening to the other? It's also going up, so positive. If I were to trace out the pattern, would you use a line? Yes, linear. Association between the size in carats of the gold and its price. So, giving the context of the question. And hopefully that should make sense. If it's a bigger jewel than or a bigger bit of gold, then its value is going to go up. As one goes up, the other goes up. Let's do one more. So the terminology for strength is not super exact. They'll usually take a broad scope of answers. So, for example, on this one, I would say that there is a moderate, or maybe moderately strong. I wouldn't say it's a weak association, but I wouldn't say it's like a definite strong. Direction? Negative this time. Obviously, we're using a line. Between internet usage and age. Internet is still not a word, apparently. Maybe one day we'll discover the World Wide Web. Yes?
So if the association is super strong, and it's just a couple outliers, would you still say it's strong, or would the outliers affect that?
Oh, maybe you would say, which we'll say, with some potential outlier values. So we may want to talk about what's going on with this data point and this data point. You'll notice that it has a little R here. We'll talk about that and what that means tomorrow. Some of you might already know what it means. But right now, we'll leave it and talk about it tomorrow. Okay, one more question here on each of these. What is, on this graph, last example, what was the explanatory variable? The size, and the response variable? Price. So we are using the size to predict the price. That seems reasonable to me. Here, what's the explanatory variable? Internet usage, and the response? Age. So in other words, this time we're using internet usage, how often they're using the internet, to predict their age. Which I would say, if I were to nitpick this graph, I would switch these variables and use age as a predictor for how often they're using the internet. But negative association tells me that the younger you are, the more you use the internet. The older you are, the less you use it. That's what that negative association tells me. It does not tell me about causing that internet usage is somehow causing you to, using the internet more is somehow making you younger. It is just saying, here's how I can potentially predict, use this as a predictor. And how strong a predictor is it? There's some homework. And I would like you to have out your calculator. All right. We're going to make sure we remember how to make a scatter plot on the calculator. And if you want to look at the same set of data I'm looking at, then it's on page 145. If you want to be looking at that same set of data. But the first place you want to go is to your lists. And the general steps we're going to use is we're going to make we're going to put our x in list 1, we're going to put our y in list 2, and then we're going to graph them in a scatter plot. Here we go. Oh, we have some normal CDF and inverse norm there. Let's get rid of that. So we got a set of data. Oops. 187. So this is my explanatory variable. This is my x that I'm putting in list 1. You always want to put your x in list 1. And then in list 2, I'm going to put my response variable. I'm going to put my y. So x goes in list 1, y goes in list 2. And now we're going to hit same place we use our box plots and histograms and all that. We're going to go into second and stat plot. Right now it's off. We're going to turn it on. And you're going to select the very first option. That's the scatter plot. Select the very first option. X in list 1, Y in list 2. Then you're going to go zoom 9 for zoom stat. And that's what your scatter plot should look like. So that's, you should have done this before. That's just making sure you know how to make that scatter plot